In this video, we are going to talk about what's called Green's theorem. This is one of my favorite topics because a lot of times the integral that you get is very simple as opposed to the original one if you did not use Green's theorem. So what is Green's theorem? So imagine that you are computing a special line integral of force dot with distance. Basically, you are trying to compute the work of a force where a particle is traversing a certain curve C, except C is not just any curve, it has to be what we call closed. Okay, so these integrals are also sometimes called circulation. So you're going around the curve and the start and the end is the same. Okay, so they meet at the same point. And also what we say, the orientation has to be counterclockwise. So just imagine some curve, you are traversing it, you're walking around, you're going to wind up in the same way, and same start and end, and then you are traversing it into the counterclockwise direction. And then what happens is that because it's a closed curve, we also assume that it doesn't cross itself and it encloses a region that doesn't have any holes inside. If that happens, then look at this region inside it, okay, that is enclosed by this curve. So instead, we are switching to a double integral over this region, we call it D, okay, and then we are going to integrate. Well, the force, let's assume, because this is Green's theorem on a plane, it has two components, P and Q. So this is going to be Q with respect to X minus P with respect to Y. Okay, and so basically what is happening here, this line integral is converted to a double integral. Now you may be wondering, why would I want to compute a double integral if I can compute a single integral by converting a double integral to like a dt? The problem is that it might actually be much more difficult to compute this line integral, and the double integral makes it very easy. So we'll look at an example. So this is our first example right there. So we've got the circulation thing, and it's sine x squared dx. So this, by the way, what is f dot dr? So dr is dx dy. So when you compute the dot product, this will be like p dx plus q dy. So this is my p dx plus q dy. Okay, so this is q. All right, so what we want to do is then convert it to a double integral, and it's going to be q with respect to x minus p with respect to y, right? That's what Green's theorem says right here. Okay, so what are we actually going to be integrating here? So p, let's compute p with respect to y. Well, the thing is, p doesn't even have a y, so that's just going to be 0. And then q with respect to x, well, that's very simple, that's 7. So this is just going to be 7, and we'll just say dA over whatever region D. Now, this is actually, there is a trick that I could show you. Imagine taking the 7 out. Now, this trick only works if you're integrating a number. If it's like a variable, then no, you cannot do that. So 7, if you factor it out, then you are basically integrating 1 over the region D. And integrating 1 is the same as computing the area of the region. So this is just going to be 7 times the area of this region. But what is this region? Let me go ahead and draw it for you. So we've got negative 1, 5. That's 1 point. We've got 4, 5. That's another point. We've got 4, 6. And then we have back to negative 1, 5. Okay, so this is a triangle. Okay, and it is traversed counterclockwise. By the way, if the direction is clockwise, you would just need to switch the sign. So everything will just become minus of what you would have gotten if it was counterclockwise. But in my case, it is counterclockwise. So all I really need to do is find the area of this region. But this region is a triangle. So this is 1/2 base times height. Base is 5, right? Because it's negative 1 to 4. And height is just 1. So that's going to be 5/2. That's it. That's the area of this triangle. So I will just get 7 multiplied by 5/2. So let's check that. That should be 35 over 2. Is that right? Yes, that's right. Okay. So now, in terms of what we're integrating, that's just 7. But I also wanted us to practice, because we are, here, and anyway, I wanted us to practice setting up the integral over this triangle. It just so happens that in this particular case, we're integrating a number, and we were able to use a trick to find this integral, but I still want to go over and review double integrals and setting up the integral as a type 1 integral. So first of all, remember that the x limits are the outside limits, and those are numbers. So this will be -1 to +4, right? Because that's how x changes. These are extreme values of x. Now, what about y? So some people would say, well, sorry, some people would say this is this is going to be from the bottom curve to the top curve. So wouldn't it just be from 5 to 6, because they look at the y values and they are 5 to 6? Well, that would be incorrect, because if all your limits are numbers, then that's a rectangle, and this region is definitely not a rectangle. So what is the bottom curve? So the bottom curve here is y equals 5, right? Because it's a horizontal line. So horizontal lines have equation y equals something, and it's at the level of 5, right? Any point on this line has the y coordinate equal 5. So that's going to be our bottom curve. That's going to be 5. But the top is not going to be 6, because the top is going to be this line. Let me see if I can draw it in green. This line right here. So we need to practice writing an equation of a line that goes through 2 points. So which 2 points do we have? So let's practice that here. Okay, so we have this line, and it goes through this point right here and this point right here. So we got 2 points. One of them is -1, 5, and the other one is 4, 6. So how do we find the equation of that green line? So first, the slope. This is x1, y1. This is x2, y2. So this would be y2 minus y1 divided by x2 minus x1. So this is 6 minus 5 divided by 4, subtract -1. So this is going to be 1 over 5. Okay, so that's our slope. It looks like it's positive, which is what should happen. Now, the y-intercept has equation y1 minus slope times x1. So y1 is 5, subtract 1/5, multiplied by x1. So that's -1. So here you got 5, and then plus 1 over 5. Now we can simplify that by bringing it to the same denominator. This will be like 25 over 5, so 26 over 5. So the final answer for the line would be y equals 1/5 x plus 26 over 5. So let's see if we can put that here. 1/5 x plus 26 over 5, and check that out.